Okay, so there's so one of the big parts, I guess, of the unit is, working with word problems. So just not just solving them, right? But putting a word problem into an equation, and also the opposite, taking an equation and writing a word problem out of it. Okay. So let's look at number 5. It says, Tricia and Melanie are both saving money for their summer vacations. They both began saving at the same time. Tricia started with $10.25 and adds $5.15 to her savings every month. Melanie did not have a starting amount, but adds $10.25 to her savings every month. Which of the following equations could be used to determine how many months M will it take before Tricia and Melanie both have the same amount of money? Okay. So I think there's a couple of key things here, okay? So let's start with, we have 2. So let's start with Tricia. So what are some of the key things that Tricia has, I guess you could say? I mean, we both know that they both started saving at the same time. But what did Tricia start off with? So again, what does Tricia start off with? It says she started with
$10.25.
Yeah, so she
And
started
add $5.
with $10.25, right? So she starts with $10.25 and she adds $5 to her savings every month. So let's go back and say, what are we looking for? What is our key here that we're looking for? So what's important here is that we're looking for the amount of months. Okay. So we don't know exactly how many months they're saving, but we know that every month that passes by, we're adding $5.15. So if we end up saying, like, after 10 months, how much will they have? Then we can just say that we're going to multiply $5.15 times 10. Okay. So that's why that's where we're going to put the M. Okay. We're going to put it next to that $5.15. Okay. So it says Melanie did not have a starting amount. So she starts off with nothing, but she adds $10.25 every month. So she didn't start off with anything, but she saves a lot more than Trisha does. Okay. So eventually she's going to catch up at some point. Okay. But how are we going to know when she's going to catch up? We'll know when they're both equal to each other. So on one side over here, this is what Trisha does. On this side, this is what Melanie does. So what should be the answer there? is going to be A. Okay. All right, anything on that? Okay. So let's come over here to these compound interest and simple interest problems. So looking at number 12, it says, Mark's mother is planning to borrow $25,000 to remodel the restaurant she owns. She contacted several loan companies and she's comparing two different options. One offers 5.25% and the other one offers 8.5%. So both are simple interest and they must be paid back in 3 years. Okay. So let's remember that our formula is this. Interest is equal to principal, rate, and time. So let's look at each company individually. Company 1 and company 2. So the principal and the time is going to be the same for both of them, which is 25,000. And the time, it has to be paid back in 3 years. Okay. What's different is the rate. Okay. So the first question, I guess, is how do we know which company is going to charge more in interest? How do we know which one of these two we're gonna pay the most? Or better question, which one of these are we gonna pay the most amount of money? Anyone? So we're gonna end up paying more at company 2 because the interest rate is higher. So to solve these, we're gonna multiply all of them together. So that's 25,000 times 3, and then 5.25%, but it has to be in decimal form. So 0.0525. So the first company will charge us $3,937.50. And the second one, same thing, 25,000 times 3 times 8.5% in decimal form, which is 0.085. So that's 6,375. Now we need to find the difference between these two because we're looking for how much more we will have to pay. So the answer ends up being H. The difference between these two is 2,437 with 50 cents. Okay, so let's now do this one with compound interest, okay? Because compound interest is a different formula. Compound interest formula is A is equal to the principal, and we're gonna add 1 to the interest rate, and we're gonna raise it all to the power of t, or the power of the time. Okay. So the same thing, we want to say, okay, Jacob deposited $6,000 into an account that offers 4.5 interest compounded annual. And the stuff should always be annual, okay? If it's months, then we have to turn them into years. If it's days, same thing, we have to turn it into years. So he makes no additional deposits. Which amount is closest to the interest Jacob will earn at the end of 10 years, okay? So our principal is 6,000. Our rate is 4.5, and our time is 10. So setting this up, it's 6,000, and then 1 plus 0.045, and to the power of 10. All right, so to solve this, we're going to add 1 plus 0.045. Let me just clear this out. So it's 6,000, and then we're going to add 1 and 0.045. And with our order of operations, we need to raise this to the power of 10. This gives us a decimal like 1.55296. Pretty big decimal. But then we're going to multiply this times 6,000. And the answer should be 9,317 with 82 cents. But here's the thing. The compound interest formula, it gives us the total of the amount, the principal and the interest together. But we're only looking to how much interest we're going to pay. So what we need to do is we actually need to subtract the principal so that we know how much interest we paid. So if we subtract that, the answer should be C, which is 3,317 with 82 cents. Okay. So you really need to pay attention to what the question is asking for, because sometimes it'll ask you for the total amount, sometimes it asks you for the interest, sometimes it asks you for the difference between the two. There's a lot of ways these questions can be rephrased. Okay. So those are some of the ones that I saw miss